Hello, welcome back, and we are now going to start talking about identity matrices and inverse matrices. Okay, so and we're also going to be talking about matrix equations, and that's going to involve inverses. Okay, how to solve those is going to require inverses. So let's start with some definitions. So the identity matrix, okay. So the identity matrix denoted I sub n, where n is the dimension of the matrix, like an n by n matrix. So the identity matrix I sub n for matrix multiplication is the n by n matrix that has ones along the main diagonal, and then all the other entries or elements of the matrix are zeros. So here are a couple of examples of identity matrices. So we have the 2 by 2 identity matrix, which is 1 along the diagonals, zeros along the other diagonals. So the main diagonal is always the diagonal that goes down from left to right. Okay, so this is the main diagonal. So those are all ones. All the other elements are 0. And if we look at this one, I3, we see the same thing. We have ones down the diagonal and we have zeros everywhere else. Okay? And it's called the identity. Now, it's called the identity it's the identity in multiplication, matrix multiplication, just like the number 1 is the identity element in the multiplication of real numbers, right? Because we know that any number multiplied by 1 is equal to itself, right? And it doesn't matter which side, right? So the identity matrix is the identity similarly for matrix multiplication. Along the same line of thinking, okay? So notice here that because it's the identity, just like with regular multiplication with numbers, if you look at matrix multiplication along with the identity, we know that A times I sub n is equal to A, and I sub n times A is equal to A. Okay? Now remember from previous discussions that it's not necessarily true for general multiplication of matrices that these two hold, right? But with the identity matrix, it has to hold, right? So it's a square matrix, n by n, that's what we call a square matrix. The number of columns and the number of rows are equal, okay? So we have a square matrix and it works in both, so the commutative law works for the identity matrix, okay? So let's do an example and we'll go on.